Hello everyone, welcome to my channel Knowledge for You. Today I am going to discuss the most important questions from the topic flip-flops. This is the fifth unit of diploma students. The subject is digital electronics. This subject is common for ECE, EEE and computer science students. So if you go through these questions, definitely you can score more than 14 marks in your end semester examination. So let's start the topic here. That is flip-flop. So the various types of flip-flops that is covered in the syllabus are RS flip-flop, D flip-flop, T flip-flop, JK flip-flop, master slave JK flip-flop. So let's discuss the first point, that is the definition of flip-flop. Define flip-flop. So it may be asked for 1 mark. That is, flip-flop is a combination logic circuit. So flip-flop is a fundamental unit, a basic building block for sequential logic circuit. It is a bistable device. It changes its state after the application of clock signal. So these are the 3 points you have to write if the definition comes. It is a fundamental unit of the sequential logic circuit. It's a bistable device. It changes its state only after the application of clock signal. Next question is, what are the types of flip-flop? This is also for 1 mark question. The various flip-flops are SR flip-flop, JK flip-flop, D flip-flop, T flip-flop and master slave JK flip-flop. The next question you can expect is, draw the circuit diagram of SR flip-flop, JK flip-flop, D flip-flop and T flip-flop. So let's see here. So here I have drawn the circuit diagrams in a simple way. So if you remember one circuit, you can draw the rest of the flip-flops. See here, coming to the SR flip-flop. So this is a NAND gate you have to draw. So this is a NAND gate. This is a bistable or cross-coupled connected device. So in exam, if you get the question, draw the NAND latch, then the dotted line which I have shown here, this is the NAND latch diagram. So a flip-flop is constructed basically by using a latch, but the difference between latch and flip-flop is latches don't have clock signal, whereas flip-flops have clock signal. This is the fundamental difference between latch and flip-flop. Please do remember. Latches is also a bistable device. It is a cross-coupled connected device. Flip-flop is also a bistable and cross-coupled device. But the only difference is this is a latch. Latches don't have clock signal, whereas flip-flops have clock signal. So let's see the diagram first. So this is a NAND gate you have to draw. And this is the output of NAND gate, Q and Q bar. These two are the complemented output to each other. This output is connected as input to this one, and here this output connected as input to this one, and these two inputs for these NAND gates are connected to additional NAND gates over here. This NAND gate, one of the input is S input, and here one of the input is R input, and the common signal to these NAND gates is clock signal. Here S stands for setter, R stands for reset. Setting means making the output as 1, and resetting means making the output reset to 0, clear to 0. So this is a fundamental circuit diagram of SR flip-flop. Now see here, if you remember this SR flip-flop, you can draw the rest of the flip-flops diagram. That is D flip-flop, JK flip-flop and T flip-flop. So let's see here how to draw the D flip-flop. So all of you see here. If I hide this NAND gate, the rest of the diagram is similar to a SR flip-flop. So the only thing you have to add additionally here, to this NAND gate, you have to connect additional, this is a S input actually. So this input you have to extend, and from this input you have to connect an additional NAND gate. So this one is applied to your R gate. Okay, R input. So look at here, S input is similar to your D input, but R is equals to what here? D bar. R is equals to what here? D bar. So this is the difference you have to remember in the circuit diagram. So these diagrams may also ask for 3 marks. Draw the circuit diagrams of SR flip-flop, D flip-flop, JK and T. Now look at here JK flip-flop. See here, this also diagram is similar to your SR flip-flop. Here J input is similar to S input, K input is similar to R input, but the only difference is from this Q, this is the Q output, this is the Q bar output. So from this Q bar output I have taken a feedback. So look at this connection. From this Q bar output I have taken a feedback and applied as input to the Jth NAND gate. Similarly from this Q output I have taken a feedback and applied to the input of this NAND gate. So that's how it makes a JK flip-flop. That's how we have constructed a JK flip-flop from the SR flip-flop by taking the feedback connections from their outputs. I hope you are understanding how I am drawing this. And the next one we have T flip-flop. T flip-flop is very simple again. If you remember the JK flip-flop, see here, this is a J input, this is the K input we have. So what I have done means I have taken a common connection. So I have tied the inputs. I have shorted the inputs of J and K and connected the common input, that is the T input. The rest of the thing remains same, that is J is equals to K is equals to T. Here T stands for toggle. Here T stands for toggle. So toggle means I have already told you in my previous sessions, the previous videos which I have uploaded, in that I have discussed what is toggle. Toggle means the complement of the previous output. Toggle means what? Complement of previous output is called toggle. This condition is this question is important for 1 mark. That is a complement of the previous output is called a toggle condition. Okay, so these are the circuit diagrams. If you get the question for circuit diagrams, you have to draw this by using the NAND gates. And the next question, most of the students may get doubt that why we are drawing the circuit diagrams by using only NAND gate, and we have alternate option, we can draw this by using NOR gates also. The reason why we are preferring NAND and NOR gates to draw this circuit diagram is NAND and NOR are called as universal gates. NAND and NOR are called as universal gates, which you have already studied in the first and second unit, hope so. By using these gates, we can implement the other gates too. That's why they're called as universal gates. And that's the reason we are drawing all these flip-flops by using NAND and NOR only. Okay, please comment me if you want the previous lectures also. That is a lecture based on first unit, second unit conversions, because I am making this video by considering only in the end of semester examination to score 14 marks to make you clear digital electronics subject. So please like, follow and share these videos so that you can get further updates from me. If you motivate, then only I can make the videos for you to clear your exams. So next question is logic symbol or block diagram. The next question is logic symbol or block diagram. So see here, most of the students get confused which diagram they have to draw. So in exam, if you get the question, draw the block diagram of the flip-flop, then you have to draw this. Since it looks like a block, therefore you have to draw this diagram. So first one we have SR flip-flop, so you have to draw the block one. The inputs are S input, R input, and next additionally clock input we have, and the outputs are Q and Q bar. Similarly JK flip-flop we have J input, K input, clock input, Q and Q bar. T flip-flop, T input you have to draw clock, Q and Q bar, and the last one is D flip-flop, D input, clock, Q and Q bar. So next we'll discuss the truth tables of these flip-flops. So truth tables is also equally important for 3 marks. See here, if you combine all these circuit diagrams, block diagram and truth table, then it makes you a 5 mark question. So no need to remember additionally. So next we have SR flip-flop. So this is the truth table. So the operation of any logic gate or operation of any flip-flops can be well understood by using its truth table, because truth table explains the relation between input variables and output variables. Okay, that's the reason. So we will use truth tables in digital electronics. So it gives a relation between input and output variable. So see here SR flip-flop. For the SR flip-flop we have the inputs S input, R input and additionally clock input. So flip-flop is the only circuit which does not changes its state unless and until clock signal is applied to it. So I can say that clock is simply behaving like a switch for this. When the switch is on, then the circuit is going to be enabled and operates. If it is off, it does not function or operate. Like that you can remember. So for inputs we have the clock input, S input, R input. So since we have the 3 inputs, the total number of combination for 3 inputs is 2 power 3, that is 8 combinations we get. So here we get for 8 combinations 0 1 2 3 4 5 6 7. The binary number for the binary value for 0 is 0 0 0 0 0 1 0 1 0. How do we get this? Because it is what 2 power 0, it is 2 power 1, 2 power 2 means 4 to 1 code. So you have to write 4 zeros 4 ones, 2 zeros 2 ones, 2 zeros 2 ones, 0 1 0 1 0 1 0 1. Okay, this is a shortcut to remember, or else you can write 0 means 0 0 0. So already you have known this fundamental thing. So look at here. When the clock input is 0, the output is not going to change, no change. So till this state, the clock input is 0. Till this state, the clock input is 0. That means the flip-flop does not function, does not operate. It will maintain the previous state only. Therefore, it is nothing but no change state. And next, when clock is 1, and S input is 0, R input 0, in that case also the output is not going to change, no change. Next, when clock is 1 and S input is 0, R input is 1, then the output is 0. So I can explain how do we get this all this no change. If you put all these values to the circuit, if you put all these values to the circuit diagram, that is by keeping S0, clock 0, R0, then you can able to know how we are getting the outputs. But I'm not going to explain that in detail because this is the final revision session I'm going to give you to get the 14 marks. Okay, so this is nothing but when clock is 1, S0, R1. See here, output follows S input. Output follows S input. If S is 0, output is 0. If S is 1, output is 1. If both are 1 and 1, this state is called as forbidden state or prohibited state. So this is unused state. Okay, but in textbook, you will find in shortcut like this. If clock is 0 and S's value is X, R value X. Here X means the S value can take either 0 or 1. R can take either 0 or 1. So unless and until clock is 0, the flip-flop does not change its output. The flip-flop does not change its output. So that's when textbook it will give you like clock 0, S is X, R is S. Irrespective of the values of the inputs, if clock is 0, the output is not going to change. The actual operation starts from here. If clock is 1, but here S is 0, R 0, in this case also the output is not going to change. But when clock is 1, S 0, R 1, so the output is 0, output 1, and when both are 1 and 1, the output is what? A forbidden state or unused state. So for example, I will show you here. See, if clock is 0, this input is 0, here it is S, here it is 0, here it is R. So if one of the input of the NAND gate is 0, what is the output we get? We get the output as what? 0 into S, 0. 0 bar is what? 1. 0 into R is 0. 0 bar is what? 1. So this input is 1. Here this input is Q bar. So we are multiplying. NAND means multiply these two and put a complement over it. So 1 into Q bar is what? Q bar. And again I have a bar over it. What is Q double bar? Q. See, here I am going to get the same state. No change. Here also it is 1 and this input is what? Q. So 1 into Q is Q. Here I have a NAND means I have to put a complement over it. It becomes Q bar. So that means I am not going to change the state. That's how we'll get the output. Okay, so for rest of the combinations you can put these values, that is clock 1, S0, or 0, you will get the output. So this is a simple example I have given you. Okay, so I hope you will remember this truth table, and this one is equally important for 3 marks. By combining all these things, that is circuit diagram, logic symbol and truth table, you can make a 5-mark question. And next we have JK flip-flop. So here also the same thing. So here we have the clock input, J input, K input. So do remember J input is similar to S input and K input is similar to R input. Nothing changed. The entire truth table remains same. But the only thing you will get the change in your last condition. When J is equals to 1, K is equals to 1, this state is called as a toggle state. Toggle means complement of previous output. Complement of previous output is nothing but a toggle. So this is the only change you will find. Rest of the combinations remains same. So here also in textbook again the same thing will be there. Clock is 0. J input is X and K input is S. Here X means it can take any value between 0 and 1. Okay, so if clock is 0, the output is not going to change. If clock is 1, J0, K0, output will be again no change. The actual operation starts from here. When clock is 1, J is 0, see here, output is 0. So output follows here J input. So exactly which happened in case of SR flip-flop. J is 1, output is 1. If both are 1, 1, this is the only change you get in JK flip-flop. We get the toggle condition. So such kind of question is also important for ESET point of view. In which flip-flop you get toggle condition? The answer is JK flip-flop. The answer is what? JK flip-flop. Okay. So in which flip-flop when both the inputs are 1 and 1 and clock is 1 is called as forbidden state. Then the answer is SR flip-flop. So that's why these truth tables are very, very important, not only for your end exam point of view but also for ESET point of view. Next we have T flip-flop. Here the input is T, and next the present output state Qn we are taking. So if 0 0 1 1 0 1 0 1, then the output we get the next state output is both are 0 0, output is 0. If it is 0 1, the output is 1 1 0, output is 1 1 1, it is 0. Okay, so one more T flip-flop truth table also will be there by using a clock signal. Here we have a clock, inputs are 0 0 1 1. In some textbook the above diagram, the above truth table will be there, and in few textbooks this truth table is there, that is 0 1 and 0 1. And here we have a output. See here, if clock is 0, output is what? No change. Output is what? No change. But when clock is 1, when clock is 1, but here T input is what? 0. So here you get a same 0 only. But if clock is 1 and T is 1, then the output is what? Toggle. Then the output is what? Toggle. Then the output is what? Toggle. That is Q bar you'll get. Okay, this is another truth table for your T flip-flop. So you can write either this one or this one. Here input is T0011, present state output is QN0101. Then the next state output will be, see here, it is just like a XOR gate. Okay, XOR gate, or simply you can write with T is 1. If T is 1, output is what? More complemented of the previous state. So the complement of 0 is what? 1, and the complement of 1 is what? 0. But when T is 0, the output is not going to change. So 0 remains 0, 1 remains 1. So I hope you have understood this. If T is 0, output is not going to change. 0 remains 0, 1 remains 1. But if T is 1, the output it will be complement of the previous one. That is 0 becomes 1, 1 becomes 0. So the next state output will be, since it looks like the operation of XOR gate, for odd number of ones, the output is 1. 0 1 1, 1 0 1. That's why the next state output is given as T XOR operation Q1. Okay, T XOR operation Q1. And the last one we have D flip-flop. This is the simplest and easiest one. Okay. So D stands for data flip-flop or delay flip-flop. Here we have the inputs, clock input, D input. So again same thing. If we have two input variables, we get 4 combinations. 0 0 1 1, 0 1 0 1. If both the inputs are 0 0, that is if clock is 0. If clock is 0, irrespective of D input, that is X, irrespective of D input, output is not going to change, no change. But if clock is 1 and D is 0, then output is equals to input. If D is 0, output also 0. If D is 1, output is also 1. If it is 0, it is called as reset state. If it is 1, is called as set state. Set means making the output to 1. Reset means making the output to 0. So since in D flip-flop, output is equals to input. Output is equals to input. That's the reason D flip-flops are preferred in designing registers. D flip-flops are preferred in designing registers, whereas JK flip-flops are used in designing counters. JK flip-flops are used in designing counters. Along with the JK flip-flop, T flip-flops are also used to design the counters. And the last topic I'm going to cover is difference between combination logic circuit and sequential logic circuit. Most important question for 3 marks. Definitely you can expect in your end semester exam. So combination logic circuit, first you have to write the definition. Here the output depends on present input, whereas in sequential logic circuit, output depends on present and past outputs. Output depends on, in sequential logic circuit, output depends on present input and past output. Here only present input, here past output also. So see here, since it is depending on the previous values also, to store the previous values it must have memory. Therefore it has memory, and it also has feedback. If it has memory, it means it does not have memory. It has feedback means it does not have feedback. But which one is the simplest process? Which one is easy to design? Combination circuits are easy to design. Since it involves a feedback, therefore it is difficult to design. And since it does not have feedback, therefore the operation is faster. That means combination circuits are faster one, whereas the sequential circuits are slower one. And next, the basic building block for combination logic circuits are logic gates. The basic building block for combination logic circuits are logic gates, whereas the basic building block for sequential logic circuits are flip-flops. And the last one we have, the examples of combination logic circuits are parallel adder, and for sequential circuits are serial adder, flip-flop, registers, counters, memories. And here it is the examples: parallel adder, multiplexers, demultiplexers, encoders, decoders, extra. You can write anything. So this is the most important question from the 5th unit, that is flip-flops. So don't go to exam before reading these questions. Definitely it improves your score. And those who are thinking that their digital electronics subject is very difficult to pass, so I make sure that if you go through my videos, definitely you can score 14 plus marks. 14 plus marks. There is no scope of getting failure. Okay. So please like, share and subscribe to my channel, and forward to your friends, those who are studying diploma, not only diploma but for BTech also. Thank you for sharing my videos.